In this video, we'll talk about the architecture of our adaptive model router and what we've built so far. If you haven't watched my previous video, I'd recommend you watch that. In that video, I kind of went through a high-level design of what we will be building in this video series, which is an adaptive inference router that kind of covers a high-level perspective of what I will be building. So before we go and build and plug things into my main lab, I kind of wanted to try a couple of things in a staging environment so that once I have my things validated here, then I'll eventually plug and play my things into my main lab, right? So that's the approach that I want to take. And generally, that's the approach we take in building things as well, right? You try a few things in your dev environment, and then you push it to your staging, and eventually it makes to production. So let's talk about what we have so far. So let me go through this diagram first, and then we'll go through that document. So what happens is I have a UI pod, right? So from my UI pod, we'll send all of our traffic to the router pod. So what the router does is that it will look at the Redis pod, right? So this Redis will store the health of our backend vLLM pods. So based on that pods, that information will be passed to the router, and then based on what kind of matrix are available there, it makes the decision on where to send the traffic. So let's look at this example, right? Let's imagine a new query comes in through our UI, and then it hits the router. So now router is going to check our Redis, right? It says that okay, vLLM1 is in a green status, vLLM2 is in yellow, the GPU utilization is around 35% here at 72, the queue depth is 12. That means how many how many requests are in the queue. Here only 2. The KV cache utilization is at 40%. Here it's at 78. Number of active requests 15 and 3. So we can see that from these matrix that this backend is quite busy, right? Because KV cache is almost 78. We have a lot of active requests and a lot of the requests at queue, right? So seeing this, what the router does is that okay, I won't be sending the traffic to vLLM2. I will be sending the traffic back to vLLM1. So this is how the router pod makes the decision, right? And all of these matrix will be scraped in my lab in my production environment, let's say, from the actual health of my Kubernetes cluster and the nodes. So let's talk about how we have implemented this in staging and what I have so far. So I have this fake UI pod from where I'll send my curl request, and then the router pod will get all of these requests. This will read the backend information from my Redis pod, and then based on that it makes a decision, right? But I have a fallback here. Let's say if for some reason these Redis pods go down, then there is a config map where which creates a backends.json file, and then it reads that JSON file and makes the decision. So the reason I have this is just in case if Redis pod goes down, we still want the routing to be there, and that file gets updated as well, right? So how do we define which vLLM backend gets to serve the traffic? We kind of spoke about certain matrix, right? So what I have done is we have this scoring system. So there are a couple of points that gives you certain scores. So let's say if you're in a green state, you get 0. If you're yellow, you get 50. And then if you're red, you get 100. Apart from that, for KV cache utilization, you get 40 points. So if your utilization is at 70%, we do 0.7 times 40. And then for each queue, I'm assigning 3 points, and GPU utilization here gets 0.1. So the reason it's lowest is because GPU utilization is not necessarily a bad thing. It means that your GPU has been utilized properly. Metrics like KV cache and the backend status would be more important for me to decide where the traffic goes rather than going through something like GPU utilization, right? So let's imagine a couple of scenarios. And so both of them are healthy, right? So let's say I have two backend pods, vLLM1 and 2. Both of them are on green status. So KV cache is 25% here, and then it's 55%. So I have 1 request in my queue. I have 3 in my queue here. My GPU utilization is 30 and 45. So based on all of this, a total score will be calculated. And as you can see here, vLLM1 gets 16, vLLM2 will get 35. So based on this, traffic will be routed to vLLM1, right? Because it has the lower score. So another situation where where one of them is degraded. So same math is done, and then this final score comes over here. You can see it's 35.5 versus 149. So traffic will be routed to vLLM2. And a different situation where both of them are stressed. So this one here is red, that is yellow. So red means that you get 100 points straight away. And then even though if your KV cache and other things might be lower, right? Like the status has the highest point. So that point is again, if a server is if a server is on red or yellow depends on the backend matrix. So we'll go through that in the next video. But for now, let's imagine the situation where this is on red and this is on yellow. So the same thing happens, and then it turns out that vLLM2 has the lower score, so traffic will be sent to vLLM2. So a different situation, right? So let's imagine that both of our backend pods are pretty stressed. Both of them have been busy for a while, and then we decide to trigger a scaling event. So we have a new pod that joins the cluster. It goes through the same score calculation as well, and as you can see that it when it comes and joins our cluster, it will be quite free. So the score that it will receive will be quite low compared to the others one above. So now all the traffic will be routed to vLLM3. And as mentioned here, right, if for some reason the Redis pod goes down, then the router will automatically fall back to reading the backends.json from the config map volume mount. So no crash, no manual intervention will be needed. Our router logic will still be in implementation, and this is how the traffic will get routed, right? So let me show what I have in my implementation so far. So let's go with this. Okay, kubectl get pods hyphen and staging OY. So I've created this namespace in my cluster called staging. I have the fake UI pod, I have Redis, and I have my router pod running here. So this is my router pod CLI. So if I get the status of my backend endpoints, you can see that I have both of them on green. GPU utilization is at 3572. Bear in mind that it's not actually querying an actual GPU right now. I'm just hard coding these matrix because I want to validate these theories first before I go and start playing with the GPU matrix, right? So I've kind of hard coded a couple of things here. So let's say if I want to look into the root here, let me go and go. So what I'm doing is I'll exec into my fake UI pod, like kind of mimicking that I'm a user. From there, I'm trying to find out that which root is the active root right now. So if I do that, it says that the traffic gets routed to vLLM1 because of the scores. And right now, vLLM1 has 25.5, whereas vLLM2 has 74.4. So it tells you the reason here as well. And then if we look in our kind of Redis CLI here, we see that the number of queue depth is higher, right? KV cache utilization is higher in vLLM2 as well compared to vLLM1. That's why the traffic got routed to vLLM1. So let me change this, right? So let's imagine a situation where we have a higher value for vLLM1 compared to vLLM2. So let me go here and let me change the status from green to red, for example. So for some reason, our GPU is being hammered with a lot of requests, and then it goes to a red status, right? So if it goes to a red status, we'll have a look and we'll see what route are we going to take. So you can see that that got updated straight away, right? So now instead of routing our traffic to vLLM1, we're routing our traffic to vLLM2 because the status for vLLM2 server is, sorry, vLLM1 server is red, as we did the manual change here. So let me go and get vLLM1. So as we can see, vLLM1 is on status red, and then it has these values assigned. That's why my traffic got routed over to vLLM2. So if I were to change something in vLLM1, let's say, so R2, set backend, and let me change the KV cache here to 0.9. And this is a vLLM backend 1 at red, and let me set my vLLM backend 2 to a different matrix. So let's say that is red as well. It has a similar KV cache. Let's set all of these values pretty identical, right? So the only thing that I'll change here will be the number of active requests. So let's say I have 10 active requests here, and then I have 3 requests in my queue. So in this situation, the same scoring will be done, right? And it sees that vLLM1 should be better because the number of queue is less in vLLM1 and the number of active requests is less as well. So let's do a check here again. So let's say we are sending traffic. We see that we are being routed to vLLM2. Let me change this matrix in my Redis database. Okay, so that matrix is changed for both of them. So now I should be routed to vLLM1. Okay, there we go. It says that I'm routed to vLLM1. It did the math. It's pretty close. vLLM1 is at 145.5, 2 is at 148.5. And based on that, whichever is the lowest gets to serve the traffic. So that is the concept that I kind of want to try, right? But now what I'm doing is I'm kind of hard coding all of these matrix myself. But we know that in my environment, I have all of my monitoring pods. We are exposing the right matrix. So all of these information will be kind of gathered from our Prometheus, right? From the actual state of the cluster. And based on the actual state of the cluster, we'll decide where the traffic will go. And if things go bad for both of them, then we'll eventually look into scaling. But scaling would be the last part of my lab. For now, I kind of want to build these things first. And then the reason I kind of wanted to do in staging environment was as well because I think it'll be a bit less complicated if I try something like this in staging, right? Because I can now easily hardcore the matrix, and I can see if the logic works or not, if the traffic flow goes as I expect or not, right? Once I have this, then I can kind of take the things that I learned from here back to my production environment and see more active results. So yeah, thank you for watching this video, and see you again.